our final presentation for the Clockwork Asset and Building project. Over the next 10 minutes, we will present the problem we solve, our progress from Spring 1 to 3, and our plan for the future, and our reflections on our teamwork. So I'm Phương Bao Minh Nguyen, and I'm joined by Benjamin, Hui Tin Min, and Thi Min Ha. So the problem we were tasked with solving was the complex manual process of managing appointments for Clockwork. So businesses struggled with disconnected system for creating events, sending calendar invites, and tracking attendance. Our goal for the system, our goal for this semester was to build the iCalendar, the ICS portion of the system. So basically, create a seamless flow where a user can create an appointment and send an access invite and track attendance, which lay foundation for building. So now uh, I will pass to Benjamin to discuss our system architecture and Sprint One plan. Thank you.
Thanks, Mina. The next thing we developed was a high-level diagram that shows the entire flow. It's broken into three key phases: appointment creation, where the admin creates an event; appointment acceptance, where the customer receives an invitation to that event, either through the Clockwork application or via an ICS file through email or SMS; and phase three, which is appointment attendance, where the user can check in via geolocation or manually themselves or by the admin of the appointment. With this architecture in mind, for Sprint 1, we focused on planning. We conducted a gap analysis of the existing Clockwork repositories, and we researched key technologies to implement, such as MinIO for local storage. We also designed the complete system architecture, including the database schema, the low-level diagrams, and a couple Figma wireframes for the front end. This was the database schema we came up with. It organizes data for users, appointment resources, and attendance logs. And this was the low-level diagram that we came up with that extracts data and exposes it all via API endpoints. And finally, these were the Figma wireframes we came up with to map out the user flow. This planning was essential for a smooth development process, which is in the next sprint. And they did require a couple changes later on, but these were the framework. I'll now pass it along to Hui and Tin to show the backend we built in the following sprint, Sprint 2. Thank you.
Thank you, Ben. Now we will move on to the Sprint 2, which is focused on the development of our system. So during this sprint, we have set up the Postgres database based on our database schema design. We also created all of the APIs and endpoints needed based on our low-level diagram. And of course, we also test those APIs as well to make sure they are functional. We also designed the wireframe for the front-end app, and we also created the frame, the skeleton for the front-end web app. And in addition to that, we also do a bit of searching and exploration into the mobile application. Moving on to the database. So here is the database schema of our system designed for our API backend system. So basically, like the users is the central database, and you can see a lot of other tables associated with the user table, such as the attendance, appointment attendance, attendance log, appointments, etc. And these will help to accommodate the backend API system. We also push this database schema to the repository. We included the SQL script and also a Docker Compose file, so that when you initialize it, it will automatically create the database and populate it with the sample data. We also inform other teams about our changes in the database. And moving to our endpoint API's endpoint system. So initially, we were working on another repository which uses the TRPC API, And now that we move back to the paperwork uh, repository, we have made a few changes. The first one is that we temporarily put aside the admin user separation. For now, we would want to focus on making sure that the APIs are functional first. So for that, we assume that the user who created the appointment will automatically be assigned as the admin for that specific appointment. And also because like we changed to back to paperwork repositories, so we moved from the TRPC APIs back to the traditional REST API, which is much more convenient for us. And our backend API system can also generate and send the ICS to other attendees via email. And this is the list of the API groups that we created. So we have the activities, appointments for creating appointments, adjusting it, etc. Appointment attendees for managing attendees within an appointment, and all of the others API groups here. We combine some of the APIs into groups like this so that we can easily manage the APIs. Like we can easily navigate to each of the API group to find the APIs and make changes to that. And this is the more specific endpoints within each of the API groups. So with all these APIs endpoints and these API groups, we hope that these would be sufficient for us to it would be sufficient to accommodate all the features needed in the front end web app. And of course, after creating the APIs endpoints, we also have to test them. And for that, we use Swagger to test the APIs endpoint because it has the UI that makes the API documentation way much more interactive. And in each of these API testing node, it also have the example request payload for each of the endpoints so that now we don't have to remember how is the JSON format for the payload for each of the APIs anymore. Now we can view them directly in this API node because each of them will have the example payload. So this would save us a lot of time and make it make us more efficient in testing these APIs. And it also helps the exploration of the API system much faster since Swagger provides a very interactive UI. And now I will pass along to Tin Lương for more in-depth back-end system.
Thanks, Hui. A key part of our backend was the attendance magic logics. So we implemented two main endpoints. The first is the manual check-ins, which includes conflict prevention to stop the duplicate check-ins. As you can see from the 409 conflicts here, is the error. And next is the second one is shown here is the geolocation check-ins. This API will verify the user's physical locations against their event's location, and this will return error if they are too far away from the events, for example. And this logic is crucial for tracking attendance accurately. Um, we also investigated their existing mobile app, and we discovered it was built on their outdated Expo SDK and rely on their deprecated AWS Amplify service, which made it like non-functional. We documented this challenge thoroughly for the next team to do, and now Mincal will show you how this all comes together in a Sprint 3 front-end demo.
Thank you, Tin. In Sprint 3, our goal was to build the complete front-end experience, integrate the backend and get the ICS distribution working. And we started by updating the create new appointment screen. Just like user can fill in the details, add invitees by email, and set a check-in method. And once created, the event appear instantly on the appointment calendar views. And the most important feature is the ICS distribution. Here you can see an email invitation sent by the system with the ICS file attached, and this allows the user to accept it and add it directly to their personal Outlook or Google Calendar as you can see here, your appointment on the Outlook calendar. And we also build the manage appointment dashboard. From here, an admin can see all the upcoming events, their status, and filter them. And they can also manage the detail for a specific appointment, add more people, or resend an email. We then implemented the check-in flows. This is the geolocation prompt, which asks for user location. And we also have a successful manual check-in flow. And finally, the admin's page to mark attendance for the user. This completes the full appointment lifecycle we planned. And we also added the keyboard accessibility shortcut for the power user. And now Hannah will discuss our future plan and reflections.
While we completed the core appointment flow, we set a clear roadmap for the next. Our first priority is to integrate our new backend with a rebuilt mobile application. Second, to integrate Snipe IT for access and room booking. Finally, the attendance data we now collect can be used to build the project's building component, completing the original vision. A key part of this project was reflection on the challenges we faced. Our first major challenge was discovering we were building in the wrong repository. We had to pivot quickly, reconstruct our database and paperwork, and adjusted all 66 endpoints to work in the new environment. We also updated Figma wireframe to reflect the changes. This was a difficult but valuable lesson in communication and adaptability. Our second challenge was the outdated mobile application. As mentioned, the old Expo SDK and deprecated AWS services made it non-functional. We've documented this thoroughly for the next team and suggested to remove the AWS dependencies entirely. Once the next team sorts out the problem, we can start implementing our parts. These challenges greatly improved our problem-solving skills and team coordination. This project was a true team effort. We've learned to coordinate across backend, frontend, and architecture. Everyone contributed to the final product you saw today. On behalf of all of us, thank you for your time.